All right, so let's talk about Cheater's Hangman. All right, so there's a couple different dictionaries you're going to need for that. A couple different hash maps. Sorry, I'm teaching dictionaries in Python right now, which are the same thing as hash maps, but I have to keep swapping between the two terms. So now the hash maps you typically will be using to categorize stuff. So say like we're reading through our file, right? We might want to create a hash map where we have all that contains all, one of the first things you'll want to make is like a hash map that goes from integer to, and this looks a bit scary, but I swear it's not. Array list of string. It only looks scary because of all the generic brackets, your less than, greater than signs. And what is this doing? Well, this is a categorization. It's saying, hey, we're creating a map that given a key returns, given a key, which will be an integer in this case, returns a list. Okay, the key in this case is going to be basically the word size. So let's go ahead and say like 3. And the list is all the words that are that length. The, all, she, and so on and so forth. And 4, right, would contain word, bird, and look, book, all the 4-letter words. And then 5 would contain all the 5-letter words, like words and birds and looks. And yes, I'm being quite lazy right now. Books. Right, and so on and so forth. So that's basically the first thing you're going to want to do, is read the file and separate out the words. So just so you can make sure you're getting how that the file reading is being done, and the other stuff is being done. Now, I'm sure when I said 4-letter words, a lot of us were thinking might have had a little snigger in our back, a little bit of a laugh because 4-letter words does have a meaning. And I just want to alert you to the fact that this is a dictionary file, specifically a dictionary file used for spell checking, which means it does have all of those 4-letter words in it. Now, so just be aware of that. Let's see. So one of the things I would want to point out, though, this is a perfect time to talk about the Scunthorp problem, which is, why don't I get rid of all these things in the dictionary? So Scunthorp, the Scunthorp problem here is basically a problem that you will run into if you're ever trying to design a filter of some kind. All right. So for instance, this is a Wikipedia blocking a username because it's Scunthorp, because it has a 4-letter word that's, that is profanity in it. This happens a lot of times. For instance, trying to register the web domain shiitake mushrooms. Trying to Craig in Scotland, Craig Coburn was unable to use his surname with Hotmail, and this one's even more hilarious. Okay, he had problems with his workplace email because his job title, software specialist, contains the substring Cialis, which is an erectile dysfunction medication that's often used in spam emails, right? So spam emails saying you can get, these medicines for your problems. without a prescription. So you don't even have to talk to a doctor. Just send it to our totally legit website, and get your medicine. So it's been, so I find that one a bit more hilarious. There's other ones, right, that happened because in some months leading up to January 1996, some web searches for the 30th Super Bowl, which uses the Roman numerals XXX, were filtered because that string has a connotation with other things as well. So there's a lot of stuff that happens with these kind of things, typically because people do try to because people try to make a filter to make sure that basically that you can't search for something on the web on this, or you can't have a username that the entire username would actually be a harassment in itself, that kind of thing. It is a very difficult problem to basically, how do you tell whether somebody is trying to create something that's legitimate versus how do you create something that is basically not. It's a really actually hard and interesting problem. Let's see. So it is real. And I mean, like, a lot of this actually has to do with people's names, which is unfortunate. Like, substrings of people name just got them unfiltered. Sometimes, I mean, I don't know about Kahoot, but I mean, like, it's fairly straightforward. I don't feel the need to spell out certain examples. You can see them on the screen. But it's like these things are fairly obvious. So anyway, you might just be aware that that because of this, right, not only are the words in the dictionary that are 4-letter words, the ones that I do try my best not to say in class, but also you've got words that that basically that will have substrings that might unintentionally be revealed for either disturbing or hilarious results, depending on the context. Okay, so you play enough games of Hangman, you'll get something like that happening. And again, I just didn't go through all the 100,000 words in there because that's not a problem. If I can't automate it, I don't want to. And why deprive you of the teaching opportunity for giving you the name of this filtering problem? All right. So moving on to that, how in the world do we actually do the Hangman thing? All right. So how does the computer cheat at Hangman? Well, let's go ahead and use some 4-letter words, right? Let's go ahead and pretend that we are playing Hangman, and we've got some 4-letter words here. I think actually I want to maybe make that a bit smaller. So let's go ahead and black pen. Okay. And so there is our thing. And now let's go ahead and let's assume that basically we're playing Hangman. We've got 4-letter words. And let's, for the sake of argument, to make it easier for us, that let's go ahead and basically make it so that the English language doesn't have actually so many 4-letter words in it. Maybe our only words are look, book, took. Let's go and do wolf. Oh, duh. I feel dumb. Okay. Feel dumb now, of course. So look, book, took, wolf, flow. Let's go with heal and that and let's see, tool, and I need something else with double O's in them. Let's see. My yeah, cool. Cool sounds cool. And it's good because it will also get filtered out later. Okay. So let's go ahead and assume that we're playing Hangman. And what's going to go on is we get a my Zoom is hearing my child running around downstairs, and it is saying, "Hey, are you playing music? Set up professional audio in audio settings." I'm like, okay, look. So let's go ahead and assume that basically these are the universe of 4-letter words we know. Okay. So what are we going to do? Well, let's assume that the user guesses the letter E. Not a bad first guess, considering that E is the most common common letter in the alphabet, right? So what's going to happen as a result? Well, what we're going to do is that we need to take a look and see how what the user guessing E means for each of these letters, right? So let's look. So what we're going to do is that we are going to create a new map. So we're going to create a function that takes in, and our function doesn't really need so much. We're going to go and call this function create word families. Okay, and it will take in a list of strings, which will be our word list. In other words, this is all the words that we can currently use. Not all the words that we know, all the words that we can currently use, which happens to be all the words we know right now. And we're going to take in also a set of characters called guess. A set of characters called guesses, which basically will be like the E that the user has put in. So we're going to pass in all this information: the look, the took, the flow, the cool, all that stuff. So now what do we do with that? So what we're going to do is that we are going to take in, let's go ahead and go to the pretty pen. Okay. So what we're going to do is we need to create word families. What we're going to do is we're going to categorize each of these words based off of what the based off of what would be revealed based off the guesses that have been made. So the user has guessed E, so now we have to update our word families, which we didn't have any, or they all belong to the same one. So let's look at look. If I had decided to go with look as my answer, right, look would reveal blank, 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 right? Everybody in agreement with that? How look, with the letters that have been guessed so far, look is blank, 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 blank. Make sense to everybody? So what I'm going to do is I'm going to set up this as a category. The string blank, 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 blank is going to be a category. And the list of all the things in this category is going to be look to start out with. Now let's look at book. We've guessed E. Book belongs into this blank, blank, blank category as well. Make sense? As well as wolf, because none of the letters in wolf have been guessed. Neither flow. Okay? Neither. And now will we go to heal? Let's add one more word. Them. Okay. So, what does the category that heel belongs to look like? What category does heel belong to? Any takers?
1E, index 1.
That's right. It would be blank E blank blank, right? Because if, for instance, we were playing the game and we had a real game, one way we weren't cheating, and we'd chosen heel as our answer, that was what we would do. So we'll put heel into that word category. That goes into here, tool as well as cool, as well as cool. Come on. It's cool. And actually cool is the last one. And then them, which I just added to kind of show you. Them has one E in it as well, but it's a completely different word category because what shows up is completely different. It's blank blank E blank. Make sense? Right? We've got blank. So you care not only how many of what's been revealed and how many there have been, but also what where they are located. So in word families, all you need is the word list and the guesses to calculate this dictionary. Okay, that's our map. This is what would get returned and this is what would get returned by the function. Okay, this is what gets returned. All right, now that we have this, we go into a separate step where we choose the best word family for our solution. Now, like I said, in the earliest video, cheating, the best cheating algorithm here, I think, or the easiest to implement, just kind of avoids commitment as much as possible. So what we're going to do, and we have to go with we have to select a specific category, right? And the reason that once we select that category, it locks us into that choice. Because, for instance, if we reveal an E up here, if we reveal an E up here, we can't just later, and they try to guess all the letters, we can't go back to them and say, oh, I'm so sorry, the word was them. They'd be like, that's cheating, or you did something wrong because you know, the E is in the wrong place. So instead, so we could only use words. If we go with this, we can only use words that have E right over here. Similarly, if we go with them, we'd only be able to use words that have E over here. And finally, but if we go with this big one, it's all blank still. Now, which one are we going to go with? We're going to go with the category that has the most words in it. So we're going to select blank, 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 blank. And because nothing has changed, we're going to tell the user they got it wrong. They didn't guess anything correct. And we just simply discard all these things. And this becomes our new, and this word list over here becomes the new, sorry, this category becomes the new word list. So let's go ahead and do some erasing. Okay. Okay. So look, book, took, wolf, show. So we'll get rid of heel and we'll get rid of them. Okay. Now your computer does this much faster than I did. Okay. So let's go ahead and now say our user's going, okay, I'm going to guess the letter O, which actually will produce a lot more interesting results here. So rather than going with another letter, he decides to do O. Okay. So let's suppose he uses the letter O. What in the world is that? Okay. Delete that. Okay. So let's go ahead and work on O. So he's guessed E and O. Okay. E doesn't really matter, but we got to keep track of it anyway. So let's create our categories now. So let's look at look. We have that would result in blank OO blank, right? That's look, right? It has the O's in it, so that category would be look. Same, it would also hold book and took. Wolf would be in a different category. It would be in blank O blank blank. Everybody following why this is, or do I need to explain that? That would be in blank 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 blank. And then, oh, I forgot flow. Okay, and then we've got tool and cool. Okay. Okay, so in this case, we've got 4 word categories that gets created here. Now, what may seem a bit paradoxical to you is that what we're going to do is that we are going to, rather than revealing no letters, which would say, hey, user, you're wrong again, we're going to go ahead and say, okay, you got something right. Why are we doing that? Why are we going to select the OO as the new word list? Because it gives us the most choices. It gives us the most opportunities to dodge future guesses. So we're going to go with OO. So we're going to reveal OO to the user up here. Say you got it right. You don't lose any guesses. Is everything okay? Annie? Yes. Okay. Okay. If it auto recognizes it as a shape. So let's go ahead. So gone is wolf, gone is flow, and gone is that. So what letter do we want to guess next? Any takers?
Okay.
Okay. Right. Yeah, we definitely want to use take something that actually does something useful for us. Okay, is one of them. So let's go ahead. If we do this if we split up into K, we'll get ook. So I heartily approve of this. We get ook as our choice, which will have look, book, took. And then we have OO blank. So yeah, if we do K over here, which would have tool and cool. And again, because this is bigger, because the top one has the bigger one, which isn't always the case, it's just been the case in ours, we will go ahead and we'll use that information, and we will do, and we'll basically go ahead and reveal the words that end with K. Sorry, we'll reveal that it's that the word we are thinking of ends with K. And there we go. Okay, so everybody understand the algorithm that we're using for this? It's actually a very effective algorithm, even though it doesn't seem it for this small example. And basically, once the user runs out of guesses, so let's say they make their last guess, they run out of guesses. We choose randomly from one of the remaining words here and reveal that as the answer. Like, well, the entire time I was thinking of book. How could you not get book? That's an easy word, right? Silly human, you cannot beat awesome computers. Right? But if they manage to corner you, in other words, there's only one word left, well, then they win after they reveal all the letters. Now, the best test case I can think I've been able to come up with for this, by the way, is as follows. Select 8 letters for your words. 1, 2, 3, 4, 5, 6, 7, 8. And now to check, and what I'll do typically to check to make sure that that your program is cheating properly, I will guess the following letters: E, A, okay, which will show up nothing. The next letter will be I. Now, as I mentioned last time, there's a lot of letters that end with ing. There's a lot of things that end with ing and a lot of letters that end with ion, right? So a lot of words, not letters that end with ing. So there's a lot of those words. So what's going to happen? And there's more words than not at that point. So at that point, after we reveal E and A. So once that is done, we'll reveal, once they get I, you'll see an I there. The next 2 ones you want to do to make sure it's not a fluke is guess N and G, which will basically get this. And from there, it's actually an interesting game to try to corner it, to try to corner your algorithm into something. You'll find a lot of, it will do its best to dodge a lot of guesses that you make and kind of really corner, and there's a lot of words that come up like bumbling, right? Because there's a lot of ways you can go there. You can try to corner it into a vowel, or you can try to eliminate, or you can use your guesses to eliminate dodges. But regardless, that is how we do that one. All right. I don't need to set up professional audio. Stop asking me. All right, stop share.